Hello, today I will demonstrate the simulation of the magnetic field around a bar magnet using Python, which help us visualize both the direction and intensity of the magnetic field in a clear 3D format. First, in this code we use two box object to represent the north and south pole. The north pole is color red and south pole color is blue. Additionally, we create green arrows to illustrate the direction of the magnetic field which emanates from the north pole and moves toward to the south pole. Now we will look at the result. When we run the program, we will observe that the green arrows adjust their direction and range based on the calculated magnetic field at each point. This helps us understanding the behavior of the magnetic field. This simulation clearly shows that the magnetic field originates from the North Pole and extends to the South Pole, decreasing in strength with distance. The fields from both poles have opposite directions and can cancel each other out at certain points. Next, we go to the 7.2. In 7.2, we have simulation of magnetic fields around a vertical current carrying while using Python. First, we create the wires using a cylinder object. Position at the center of the scene, extend 10 units and color grade to represent the wires. And then we create green arrows around the wire to represent the circular magnetic field lines. These arrows are placed in appropriate position and directions based on specified angles. Let's look at the result. When we run the program, we will see the vertical wire at the center of the scene, surrounded by green arrows that adjust their direction and range according to the magnetic field produced by the electric current. The magnetic fields will appear as circles around the wires, with arrows closer to the wire being longer, indicating a stronger field, and arrows further away become shorter, showing a weaker field. The physics concept is Ampere laws explain that the electric current in the wire creates a magnetic field around it, with the strength of the magnetic field decreasing with distance from the wire according to the inverse square law. And next, right-hand rules used to determine the direction of the magnetic fields around the wire. When the right finger curls in the direction of the current, the thumb points in the direction of the magnetic field. Next, we go to the 7.3. In 7.3, we have simulation of Lorentz force using Python. First, we use a canvas to set the background colors to black to highlight the display of particles and fields. And then we create constant and particle and other. Okay, let's look at the result. When we run the program, we will see the red particle moving through the electric and magnetic fields. The particle motion will be influenced by the Lorentz force resulting from both fields. And the physics concept Lorentz force, the force exerted on a charged particle in electric and magnetic fields. Particle motion, a combination of acceleration from the electric field and deflection from the magnetic field. Next we go to 7.4. In 7.4 we have simulation of Earth magnetic field, which is a dipole field using Python. First we create a sphere object to represent the Earth position at 0, 0, 0 with a radius of 1 unit and color blues to indicate that it is Earth. And then we create green arrows to represent the magnetic field lines around the Earth. Each arrow indicates the direction and intensity of the magnetic fields at various positions around the Earth. Let's look at the result. When we run the program, we will see the blue Earth at the center of the scene, surrounded by green arrows displaying the direction and intensity of the magnetic fields. The magnetic field lines will originate from the North Pole and extend to the South Pole, which arrows closer to the Earth being longer indicating a stronger field, while arrows farther away will show a weaker field. And the physics concept is dipole magnetic fields. Earth magnetic fields can be modeled as a magnetic dipole which direction flowing from the magnetic North Pole to the magnetic South Pole. And then field distribution. The strength of the Earth magnetic fields decreases with the cube of the distance from the center of the Earth, resulting in a stronger field near the pole and a weaker field farther from the Earth. Thank you.